Alright, so this is Orlando Solis from Advanced Quantitative Reasoning. In this tutorial, we're going to be talking about another piecewise function. And this is a little bit different from our step functions because you remember our step functions looked like this. They were discontinuous, but right here, this is an actual continuous line. It keeps on going on and going all the way down to the bottom. And in this case, we have Mrs. Washington. She's driving home. At certain minutes of time, she's driving at one speed, and you can check that on the slope, and then after a certain amount of time she's driving faster or slower depending on what time you're looking at her travels. So we have this. We have write a dependency statement on this, so you can write a dependency statement. You're going to be doing that in class. And then we have our chart right here. Am I supposed to see that? I didn't have that. Okay, so we have our chart right there. And we're going to have some data. We're going to go ahead and fill this up with some data. We're going to be using this for certain questions. And on number 2 it says find the slope of each line segment for Mrs. Washington's commute. So we're going to do this really quick. What I'm going to suggest is to go ahead and take our one marker, create a line going down from the top from the first point that we're going at, from left and right, and then we're going to go ahead and draw the second segment to where it starts the next segment. So we have this nice point right there that's going to be part of our next segment. So on here we have this little triangle, and from this we can actually do certain things. We can find slope, we can find everything. So first off, what I'm going to suggest you guys to do is to go ahead and do this on your own, but keep these line segments that we're drawing. Actually, it's really, really important, and actually this is used for later on. This is a really good thing to go ahead and use, and you're going to find that out in just a few moments. So we have this. We have these line segments. Now, when you think about this, we talk about rise over run. So we have 15, 16, 17, 18, 19, 20. So that's 1, 2, 3, 4, 5. So it's 5 units down. So it's minus 5. And then we go ahead and take a look at our other one, at our green line. We have, well, we have to also look at our scaling because this goes by 2s. So 2, 4, 6, 8. Who do you appreciate? So it's negative 5 over 8. So that's the slope of our first line. So negative 5 divided by 8. And that's our slope of the first line. So we're going to go ahead and find the rest of these. And you'll see that. And there we have all of our slopes really, really fast. Wow, I was so quick on that, I didn't even know I did it. Okay, so we have this right here, but now we're going to have to find the equation for each one of these lines. Now, for this tutorial, I'm only going to find 2. You guys are going to have to find the rest. So, first off, you know some simple techniques already on how to find these. Find the key points. So this is first off the first key point because that's where our line changes from the one line to the next. And segment B starts out a new segment, so this is another key point. Here's a key point. And finally we have this last key points. Key points are really, really important to us. Alright, now we already have our slope. We already have this. So to find the line, you have several different techniques that we can use. If you want, you can use slope-intercept form. We have y is equal to mx plus b. You can use that. We just pick a point that's on this line, so I'm going to pick this particular point, which is at 8, 15, and we're going to find our line. So we have our slope, which is negative 5 over 8x. Well, we don't need that x anymore. We're going to plug in those points. So we have 8 times 5 over 8 plus whatever b is equal to whatever y is. So y is actually 15. So when you go ahead and do this, you're going to find that this is 20. So our particular formula right here, we find our b is equal to 20. So our formula would basically be negative 5/8 x plus 20. And that's what y is equal to. I'm not going to put that down right now. Or we can use the recursion. We can actually use our calculator, and all we need is 2 points. For any line, all we need is 2 points. So you can use that technique using the edit. You can put the stuff right here. And then, of course, you can use the line reg to go ahead and find out what your formula is. So we're going to do that, and you'll see that. So as you can see, I found the first two, but I'm not going to find the rest because I'm going to leave that to you guys during our class. Now, this other part, this is really, really simple. It says, according to the instructions on number whatever, that we need to find the domain and range of our line. So I'm going to go ahead and show you guys some easy techniques to go ahead and do this. And it's quite simple. First, I'm going to find the domain because it's probably the easiest thing. Now remember when I used those two different colored lines? We have the green lines and we have the red lines. Well, the green lines are actually my domains for this because they match this part right here. That's actually our domain. Let me regroup that, make sure we don't lose that. So this is actually our domain right here. So we just take a look at from what part, when does that green line start, and when does that green line end. And this is sort of like our, how do we say it, our domain restrictions when we talked about stepwise functions. So we started here at 0, and we went all the way to 8. And x is somewhere in between. So right here, in this case, we look at right here, we ask the first question, what is x to 0? Is it greater than, less than, or less than or equal to, and all that? So this is where we're going to have just our, since we're just beginning this, we always pick this, that the first dot here is a closed dot. That's what we're going to assume. So right here, this is going to be less than or equal, greater than or equal to. X is greater than or equal to 0. So first off, x is greater than or equal to 0. That's our first part. And x is less than 8. And this is where we make a decision. We have to make a decision because remember, to make a function, the endpoint it has to be either greater than or equal to, or just greater than, or less than or equal to, or less or greater or whatever. So right here, I'm going to make the choice. I'm going to say this is a closed dot. So from now on, the next dot which is at the bottom has to be an open dot. The dot on top has to be closed. The dot on the bottom has to be open, and so on and so forth throughout our graph. And then here you don't need to worry about that because of the fact that we have that. Oh, this one's going to be an open dot. Okay, so we're going to go ahead and do this real quick. So now x is less than 8, just looking at right here because x is on the left hand of 8. So now, for our part right here, x is less than or equal to 8. And that's how we start this. Now we look at this one right here. We take a look at the next line. So now this starts at 8 and it goes on to 16. So from here, x is just greater than 8. So x is greater than 8, and x is less than or equal to 16. For some of you probably wondering where I get the data, I get it from here. I get it from the fact that this line right here, this line segment, goes from 8 to 16. It starts with an open dot and it ends in a closed dot. And that tells me everything I need. You guys are going to do the rest. Now, I do the same thing with the red lines. It's a little bit weirder. I'm going to go ahead and make my decision starting from here. The first one's going to be a closed dot. The second one's going to be whatever. So, closed dot. So, since I picked here at 15, where y is equal to 15, as being a closed dot, I have to choose that this one is going to be an open dot. Now, this one has to be closed dot, open dot, closed dot, open dot, closed dot. And I do it much the same way. So it goes from 15 to 20, and y is in between. So y is greater than 15, greater than or equal to, y greater than or equal to 15, and y is less than 20. Or equal to 20. So I'm just looking at line segments here, guys. So this starts at 7 and goes on to 15. So y greater than or equal to 7, and y less than, just less than because it's an open dot, 15. And you can do the rest for yourselves. Now, if we take a look at these right here, graph a line that represents segment A in your graphing calculator. So we're just going to go ahead and graph that segment right here. So, first, before I do anything else, I'm going to change my window to match this window. So first off, I take a look. Y equals, well, actually I hit window. It starts at, for the maximum x and the minimum x, so right here it starts at 0 for x, and then goes on to 34, because all we're doing is looking at the bottom lines right here. And then we look at the scale. This is at the scale of 2, so we just change our scale to 2. And then for y minimum, that starts at 0, goes on all the way to 21, and has a scale of 1. So now if we look at the graph, there it is. Perfect. Now we're going to go ahead and graph this. So negative 5 divided by 8x plus 20. And we just graph that. So we graph that. But, the line here that we have on our calculator does not match the one that we have inside right here. So what we're going to do is we need to go ahead and use the domains to restrict our data. So this is what we start to do. Now, I want you to start doing this. I put parentheses around all my functions as I put them together. Now, hold on. Let's see. Then I go ahead and just type it in. I have it already typed. So I need to make sure I put extra parentheses around everything. Now I need to use the domain restriction I have right here that I've been given. So, y, let's see, you already got that. So I'm going to start out with open parentheses. I write everything verbatim as if I'm multiplying by everything. So x, second math, greater than or equal to 0, and x, second math, less than or equal to 0. 8. Now when I graph it, you'll go ahead and just graph that. Oh, that's something extra. Don't worry about that. It just had a spillover. The calculators that you'd use do not have that problem, so do not worry about that. So then just to go ahead and do that, it's just a small correction on my part. Now, if I want to go ahead and put in B now, I have to do this. I'm going to go to the end of our particular thing, and I'm going to be adding this new function in with the old function. So that way we put everything together. So plus, open parentheses, negative x plus 23. Now I'm going to put in my domain restriction. X, second math, greater than. And then, let me see, 8. And x, less than or equal to, second math, 16, close parentheses. So now I'm going to graph. We start out first one, and then it goes ahead and goes off a little bit. So you can even see that bend right about there. The bend is right there. So that's what we're doing. So you guys are going to be recreating this on your calculators, and this should be really simple to do after a little bit. And that's about it for this. We're going to answer the rest of these questions. There's about 15 for today's work. So your prediction, sketching graphs, repeat the procedure, graph the line segments C and D, sketch your final graph. What piece of information do you need to enter in the calculator? Tell it which parts of the 4 line segments should you be graphing, and describe earlier types of functions. It can be on well, whatever. So you got to understand that this stuff right here, being able to go ahead and put together all this information is really important, especially our domain. Our domain provides us with something called domain restrictions, so that way it only draws where we want to draw and nothing else. I'll see you guys in class. Enjoy this. This is really, really fun stuff. I hope you took notes. Remember to take your notes on this. If you have to turn back the video to watch this again, please do so. And that's about it. I'll talk to you guys in class.